Hello everyone. Now I'm going to show how I connected this ESP32 module, ESP32 development module, my microprocessor to the Arduino Uno. So how I connected is through the method of UART communication. So the UART communication involves connecting the RXT and TXT uh, of the ESP32 to the RX and TX of the Uno, which is typically the servo pins right here. So these two, so the servo pins are right here, which is it's kind of not clear. So it's right here. So what are the requirements are one GND pin and two the RXT and TXT are connected to each other from between the ESP and the Uno. And then for the code to communicate, for code communication between the so this is the for code communication I have connected the win. So in ESP32 VCC is 3v3 and here win is 5v. So in Arduino win is 9v, so 5v is connected to VCC of Arduino. So I've connected it to this extra pins added right here, and the GND is connected to the GND which is somewhere right here. It's kind of hard to see because the IR sensors are covering the thing stuff here. So let's go to the code and I'll explain how I have uploaded, how I made this ESP development module to be connected to have web integration, so that I can see the sensor readings and how is the motion happening. So this is the ESP32 development. So this is ESP32 Arduino communication .ino. If you want the code, you can get it from the GitHub code, which is in the URL. So what this does is nothing much. It just creates this SSID and password, and the again the AP SSID is the access point SSID, so this is for local communication, and this is for uh, global communication. So this will happen only when the ESP32 is connected to this network, and this will happen when ESP32 is now connected to this network and will start this own customized network with its own password. So then what we have is we have hardware serial, Uno serial 2. So what this does is this is for the communication, which is really crucial for the and also one more thing is that I have added this little fs. So little fs is a type of what do we say, it's like a code upload for like uploading the HTML and all these. We create a data folder, so if you cannot name it anything else, so it should be data folder for the little fs. So for the even the download code for the little fs will be there. So what you should do is you should go to Arduino and make a new dot, not Arduino. You should go to your this PC and if you're in Windows, and if you and you should go to admin and type in and go to dot Arduino IDE in your PC and create a new folder called plugins. And from the extracted folder you should find the from the extracted file you should put it into that plugins folder. And then if you want to upload this, you should select this upload little fs to pico ESP8266 or ESP32. So this is how it should be happening. So for that what you'll be needing is the ESP32 and ESP32 and the USB cable connected to that. So after connecting it, if you should press enter. Also remember, you should close other other processing processes, like if you have a serial monitor open, it will not work. And if you have opened VS Code, which is integrated the Arduino, it will not work. So then we have this float temperature, which is 0, humidity 0, distance is also 0. So these are these boolean values. And then we have uno serial dot begin, and then we have serial underscore 8 n1, and then we have 16 comma 17. So 16 comma 17 is nothing but RXT and TXT pins in reality in the ESP32. So these pins are meant for communication. And then we have if hashtag little fs dot begin true. If this begins, then if it does not begin as true, it'll say little fs mount failed. And if it is successful, it'll say mounted. So then soft AP, I have explained this all, so nothing much there is there in that. And then so yeah, then we have this server dot on slash this square bracket and a parenthesis. So what this does is this will have this file class. So it is using fs colon file. It's a class method. So file is a method which you have created, and then we have little fs dot open, and then we have little fs dot open. So this will open this file index.html. And then we have if not file, then it will send this 404 message which is not found. And then we have the server dot stream file, which will stream this file text slash html, so the file which we created in there. And again we close this file later on. And then we have script.json style.css, which is all similar, but only thing which changes is we have this text slash css for the css type files, and then we have application slash javascript for javascript type files. Then we have server dot on dash slash data. So what this does is string json is equal to. So what this does is it sends JSON values across the internet. So JSON is JavaScript object notations. So if you might have used VS Code, there'll be this settings file which starts from .json, and it will have these formats and all that. What it does is that we have this string of temperature comma 1 plus comma. So I'll send these data through these formatting. So what it does is we will have this temperature as a key value, as a key, and the value will be the temperature as the value you get from the DHT11. And humidity same from DHT11, and from distance also it will be same. Only thing is that edge is like a boolean value, so it will be this ternary operations. Edge if true, if not it will be this false, and same for the overheat condition. And then we have this slash info. So if you go to slash info, you'll get the what do we say, the extra info what we have, but not with any format and all that, but some details which are not seen on the main page. Then we have this server if uno serial dot available. So this is read telemetry data from uno to the ESP32 to be printed on the web server. And then what it does is this will just SS scanf, which will scan all the inputs from the um, in the from the UR sensors and all the sensors. So percentage f is nothing but float data type, and edge is percentage d, o is percentage d, and all that. So this is my quite hard, quite too much to digest this. So let's so style.css is also tool is not so necessary. You can just customize that however you want. So what we so script.js and index do matter. So what we have is so .js is not JSON, so they're entirely different. So .js is JavaScript, and it's also used in many HTML web pages. So what we do is we create this async function which will be syncing itself. We have this const response await fetch slash data, and then we have const data await response dot json. So that is a JSON we get. It's the JSON data we get. So communicate. So we how we print how we communicate from the ESP32 to the web is by these JSON files. So document.get element by id is what it does is that it finds this document, it from the document which it is used which is being referred to, it gets the element by its id. So if you go to index.html and have something like id is equal to tamp, so what this does is it will find the id tmp, and then we have these all these. So what it does, it will assign the inner text inside this id to the data.tmp which we receive from the data file. So then we have set interval which is like a delay how we have in Arduino normal C programming. We have update data which will call this function every 1000 seconds, and we'll again call this a function at the end. So now if we go to rover, I'll just open the rover file. Okay. So what we have here is we have included a new library called software serial.h, which is for the communication. So what we had in ESP32 communication is hardware serial. So this was hardware serial, and in Arduino side it is software serial. So what it does is it creates this ESP serial 9 comma 10, which is the servo motors in reality, servo pins in reality 9 as 9 comma 10. And then next, so here also we have this ESP serial dot begin 9600 baud rate, and then so it prints all these data, telemetry data which we saw in commas, and all those will be sent in JSON formatting again. So there's nothing much in this but just the telemetry data code and connection with the ESP32. So now if I just connect this to the laptop, if I connect, if you want, you can start it up on your own PC. Start it up not by a PC but by connecting it to the power jack cable, which if you have the battery port or something like that, and if we connect it, you should see the red light on. So don't forget to disconnect the. There is some risk with the what do we say, the uh, ESP32, because the level shifter will have to help the shifting of the power. So if that is not there, there might be some chance, but I'm not using that. So it's not a problem until say if you have to save your um, what do you say, the ESP32. So what is happening here is there is edge detected by both the sensors. So I'll just refresh the page, and right now it shows edge detected no, and distance is 15. So if I just cover, so it'll keep updating itself because it's kind of, so yeah, you can see the 18 got is continuously updating. So you can see it's updating as usual the distance. So if I just hold both my hands in front of the IR sensor, shows yes, and if I move it away, it'll take some time, though it's kind of laggy, though the speed is quite slow. If you have a stronger network, it'll be faster, and the temperature will read the temperature data and all those. So this is nothing. Oh, no need to be worried about overheat and all that. So later on I'll explain how to integrate the webcam of ESP32 camera into this Arduino and the ESP32 rover itself. Thank you.